to making these videos is to try to make them like short and sweet. So like if you do have to watch the video in your own time, then you don't have to like watch a 45-minute video kind of thing. Yeah. So there's definitely some little hacks that you can do. So yeah, I don't want to set it up in such a way that yeah, like if you miss like 2 or 3 classes, then you know you have to spend like a few hours you know catching up. So hopefully we can make that work for us. So what I thought we would do is just do a quick review of what we did yesterday, and then today we're going to kind of take it to the next level. We'll talk about difference of squares, perfect squares, and then quadratics of the form ax squared plus bx plus c. Main difference being that now we have a coefficient in front of what we call the leading term. Okay, so before we were just looking at quadratics that didn't have anything in front. It's a slightly different process when you have an a there or some other number in front of it that's not 1. There's an extra step. So let's go ahead and try this out. So let's start off just by factoring this function right here, this quadratic right here. So yeah, this quadratic is it's fairly straightforward to factor. Is there anything that you can see that we can do just to make it a little bit easier for ourselves? Yeah, like as a first step kind of thing.
Use the instruction with grade 9 students with the last name starting with the letter B and Y. Please go down to the library.
Okay, I'm gonna stop you right there. You're thinking at like the end game, okay, which is good. That's where I want you to be. But there's something that we can do to make this a little bit easier to start off with. Do you see any? Yeah, factor to 2. Yeah, so let's get that 2 out of there. That way our numbers are a little bit smaller, and we don't have to worry about that leading coefficient. So I'm going to factor to 2. Here, I'll use a different color actually. Let's take out that 2. So that leaves us with x squared minus 4x plus 3. Okay. And now we want to factor this portion, right? So I want to set it up in such a way that I get 2 sets of brackets. Okay, I'm going to get x and then plus or minus something times x plus or minus something else. Okay, so I'm going to want two numbers whose product is positive 3 and whose sum is negative 4, right? So can you think of what possible numbers those could be? Negative 4 and positive 1. I think that would be the other way around. Say that one more time. So 4 and negative 1. Is it true that 4 times negative 1 is equal to 3? Yeah, so remember, they have to multiply together to get 3. They got to multiply together to get 3 and add together to get negative 4. So let's think about some of the factors of 3. So, I mean, 3 is a prime number, right? So it's got to be 1 and 3, right? But, okay, so we have a suggestion on Discord to do negative 1 and negative 3, right? Because that would multiply together to get positive, right? So we have to remember, we can use negative numbers here. Okay?
For grade 9 students with the letters starting O, P, B, and Y. Please go down to the library for photos. That's O, P, B, and Y. Last call for grade 9 students. We're going to go ahead and start with grade 10 students with the last name O, P. Please go down to the library. That's grade 10 students. Last name O and P. Please go down to the library.
Okay, great. So glad they're doing that right now. Okay, so yeah, we've got negative 1 and negative 3. So don't be afraid of using those negatives, especially if this middle term is negative, right? So if this guy is positive and this guy is negative, that means that both of these terms have to be negative as well, right? So what we're looking for here is x minus 1 and x minus 3. Okay. Now, did I leave anything out, or are we done? Yeah, that too. Yeah, that's a really common mistake. Just keep that in mind. That it's very common to leave out that first factor that you factored out. It's just so easy to like be just focused on the factoring part and then forget that 2. Okay. So that's kind of the style of question that we're working on now. So and we did a little bit of this last year as well. Okay, so let's talk about difference of squares, and I've got perfect squares here too. I'm gonna leave this down here. Okay, so if I asked what does a difference mean, like in a mathematical constant, in a mathematical way, what would you sort of define as a difference? Good. Yeah, exactly. Yeah. So we've got a few suggestions here that we've got like a negative or that it's subtraction, right? So essentially a difference is something like A minus B, right? If you want to know the difference between two things, you subtract them, right? Like what's the difference between 9 and 7? Well, it's 9 minus 7, which is 2. Difference of squares, though. We're talking about difference of squares. So let's think about how we would define a square. So do you have any suggestions about how we could define what a square is? Yeah, we got a shape of 4 sides. So I'm just gonna draw a square. Yeah, so that's one suggestion for a square. So that's kind of like a geometric kind of interpretation, right? A number to the power of 2. Yeah, that would be another suggestion, like a number to the power of 2. So something like 5 times 5 would be 25 because that's 5 squared, right? These are all valid suggestions. Absolutely. So yeah, so a difference of squares, what that's going to be is that's going to be one square minus another square. So a difference of squares is going to be of the form x squared minus y squared. Okay, so anytime you have a perfect square minus another perfect square, that's what we would call a difference of squares. Okay. So I'm going to give you an example of a difference of squares. So let's try this one here. Let's try something like let's see. Let's do x squared minus 16. Okay. So x squared minus 16. That's a difference of squares because here's a square, here's another square, and there's a minus sign, right? So it's a difference of squares. So if I wrote this out just a little bit differently, if I wrote x squared plus 0x minus 16, well, now we would be able to factor it. Like now we kind of know the steps that we need to factor it. We would need to find two numbers whose product is negative 16 and whose sum is 0. Okay. So what can you say about two numbers whose sum is 0? Yeah, the negative version of it. Yeah. Yeah. Sometimes we call it the opposite number. Another word for it is the additive inverse, right? So if one is like 7, then the other one's got to be negative 7, right? Because if you're going to add them together to get 0, they have to be opposites. So we're thinking of two numbers whose product is 16, but they also have to be opposites. Exactly. So this is going to be plus 4 and negative 4. This is going to be x plus 4 and x minus 4. And what we're going to want to do eventually is have the ability to kind of leave this step out. So you want to skip this step and just go directly from here to here. So in general, I keep needing to move this down a little bit. I'd have to have a whole new page. Anyways, in general, we get that the difference of squares, x squared minus y squared, is equal to x plus y times x minus y. And that's just the totally like the general form of a difference of squares. Got a couple good examples here of difference of squares. Let's try. Oh, this is a good one. Well, maybe I'll do a more straightforward one. How about yeah, let's do this one. 4 minus 9z squared. Yeah, let's do this one. I'm just going to erase this. I'll come back to it. Okay, 4 minus 9z squared. Okay, so we look at this and we say, is this a perfect square? Well, yeah, 4 times 4 is, sorry, 2 times 2 is 4. Is that a perfect square? Well, 9 is a square. Z squared is obviously a square. So yeah, it turns out that this is actually a difference of squares. So we can turn this into, well, I'm going to take this, the square root of 4, which is 2. And then I'll write plus 3z, right? Because that's the square root of 9z squared. And I've got 2 minus 3z. Okay. So this one's right out of the book. I think this is number 11. Where is it? 11E. 11E on page 167. Another good one. Okay, I want to try this one here. This one, yeah, you know what? I'm going to invent my own. I'll invent my own. Okay, let's try this one. How about, let's try just something straightforward. X squared minus 5. X squared minus 5. Okay. Is that a difference of squares? Yeah, it doesn't look like it, eh? It really doesn't look like it. Well, here's the thing. 5. Can we write 5 as something squared? Yeah, it's a good guess, probably. Square root of 5, right? I mean, it's kind of like you're sort of inventing a problem just to fix it, but yeah, the square root of 5 squared is 5. So x squared minus 5, we can write that as, well, x plus square root of 5 times x minus the square root of 5. So in this case, we're not really using integers anymore. We're not using whole numbers, but we are actually factoring it. So if in a pinch, we can kind of force these kinds of problems to work. Okay. So yeah, there's a few more difference of squares that I'd like us to work on, but I'll leave those for homework. Okay, now let's talk a little bit about. Okay, we're not quite there yet. Let's talk about perfect squares. Perfect squares. I'll call it perfect square polynomials. Polynomials. Okay. Okay, so if I have like a linear factor like this, if I have something like x plus a, okay? If I have just a regular this is what you could call a binomial where x is my variable and a is one of my constants, like this is it would actually in the real world be like a number. And if I were to square this, I get the following thing. I would get x. Well, let's just do it all out. So I'll do x plus a times x plus a, which would be x squared plus ax plus ax plus a squared, or in other words, x squared plus 2 times ax plus a squared. Okay, so this is what a perfect square. This is the format of a perfect square. Okay. So a perfect square is going to look something like this. So if I had something along the lines of x squared, let's see here, x squared, let's do plus 10x plus 25. Okay. So what I'm looking for in a perfect square polynomial is something, if I take the square root of this and double it, then I'll get on my middle term. Okay, so that's what a perfect square looks like. So that if I happen to have a perfect square on the as a constant, and I take the square root of it and I double it to get the middle term, then that's what a perfect square polynomial looks like. So this is going to be equal to something like this. So I'll have x plus, well, I'll take the square root of 25, which is 5, and it's just that squared. So between perfect square polynomials and difference of square polynomials, those two, like the goal is to just to recognize those immediately and just factor them in one step. Okay, so those are our two types where we don't really have to be searching for numbers. The trick for these is just to recognize the form that they're in. So we're looking for either a difference of squares, so something like one square minus another square, or a polynomial or a quadratic that has the form of a perfect square as its constant term, and the middle term is double the square root of it. Okay. Okay. There's just one more form of quadratic that I want to talk about today, and then we'll have some time to work. So let's talk about quadratics of the form ax squared plus bx plus c. Okay. So the thing that makes this different, so the difference is that the leading coefficient, so the leading coefficient, that is the number we multiply x squared by. So that first coefficient, that first number that we see is not 1. Okay. When it is 1, we know what to do, right? We're looking for those two numbers. The product of those numbers is the constant, and the sum of those numbers is the middle number. Okay. So when we have a quadratic of this form, it's a little bit more tricky. Okay. So this is what we're doing. This is what our goal is. Okay. So the process looks something like this. Well, I know that. Well, let's just see what happens if we have.
Please excuse the interruption. Would the next grade 10s with the last name V and Y please head down to the library for pictures? Grade 10s with the last name V and Y, head down to the library, please. Thank you.
Okay, so if I were to have something that looks like this, so if I have one linear factor that is of this form and another linear factor that looks something like this, if I were to multiply this out, well, I'm going to get a times c times x squared, so it'll be ac x squared. Then I'll get ax times d, or adx, and then I'll get b times cx, so plus bcx, plus b times d, So this is a total mess, right? Like there's so many variables here to keep track of. It's nearly impossible to think of a way of sort of, guessing what each of these numbers is going to be. There's just too many combinations. Like you could do it, but you're just going to give yourself a headache. So the process, we kind of ignore this. We don't really work backwards. What we do is we try to break it down a little bit. So if I'm given ax squared plus bx plus c, okay, if that's what I'm given, then my step 1 is to multiply a times c, okay, and find two factors. Step 2 is to find two factors of AC whose sum is B. Okay. So now instead of just looking for the like two numbers whose product is that last number and whose sum is the middle number, now we include A in the product. Okay. Okay, step 3 is to rewrite the quadratic. Okay, so we rewrite the quadratic by splitting B up into the numbers you found in step 2. Okay, and I know that this is just kind of like a sort of a boring process. I'd like us next class to sort of look at why this is and see if we can actually explain it. But for now, I want to just show you what the process is, so we have the tools to actually start factoring these things. But we will take a look at why this works. Okay, and step 4 finally is to factor. Okay, and I know that that's kind of a vague step, but you'll see what I mean when we actually try one of these out. So let's try one of the questions from our book here. Let's try this very first one. Okay, so let's try I think it's 2x squared plus 13x plus 15. Okay, so this is 2a. This is question 2a from page 173. Okay, so if this is what I'm starting with, well, my first step is to multiply the first number and the last number together. So I'm going to get 2 times 15, that's 30. Okay, that's my first step. Now I'm looking for two numbers who multiply together to get 30 and whose sum is 13. Yeah, 3 and 10. So I know that 3 times 10 is equal to 30, and 3 plus 10 is equal to 13. So we're going to turn this 13 now into 3 plus 10. So I've got 2x squared plus 3x plus 10x plus 15. So you just split up that middle term. And now what you're going to try to do is factor these two portions separately.
Excuse the interruption again. Last call for grade 10 students. Last call for grade 10 students. OPEY. If you haven't had your photo taken, you need to report to the library. Now we're going to start with the grade 11. Grade 11 students with their last name O and P. Head down to the library now. Grade 11 with O and P to the library, please. Thank you.
Okay. So now the way we've set it up is in such a way that when I factor both of these little binomials, like when I factor this and that, what's going to be left over is you're guaranteed to get the same thing. You get the same thing back. So let's write that out. So if I were to factor out this guy, well, they don't have any common factors in the coefficients, like 2 and 3 don't have anything in common, but you can factor out the x. So we'll factor out the x. So now I'm going to get x times 2x plus 3. And for this one doesn't have an x, so I can't factor out any x's. But I can factor out a 5, right? So this is going to be plus 5 times, what's left is 2x plus 3. And look at that. Now we have a 2x plus 3 and a 2x plus 3. So if I were to take this whole thing and factor out a 2x plus 3 again, 2x plus 3, then what I'm going to be left with is, well, on this one, I have an x, and on this one, I have a 5, x plus 5. Okay? So that's the process that we're going to use for factoring quadratics of that form. So when the leading coefficient is not 1, that's the process that we'll do. Now I understand that it's kind of a vague process, and I haven't really explained why we do these steps. That's going to be our goal for next class, is to kind of take a geometric approach and take a look at why this actually works. Okay. This one? Okay. So let's just say, just for example, that let's say that y is equal to 2x plus 3. I'm just introducing my very own variable. Okay. So that would make this y, right? Okay. Now, if I were to factor y out, well, let's just rewrite this in a little bit nicer of a way. So this would be xy plus 5y. If I were to factor y out, what would I get? I'll factor y, because they both have y in common, right? The first term, I've got x left over. The second term, I've got 5 left over, right? But we said that y is equal to 2x plus 3. So this is going to be 2x plus 3 times x plus 5. Does that make any more sense? Yeah. So really, we're just thinking of whatever's in the brackets as, since it's the same thing, it's 2x plus 3 and 2x plus 3. We're just factoring that out. And then what's left on this one is x, and on this one is 5. So we've got an x plus 5. Okay, so in the interest of making these videos kind of short, I'm going to end it there. I can see there's a few people on YouTube now, which is great. So hopefully we'll be all ready for tomorrow. So maybe I'll see you tomorrow, or maybe I guess Friday, or no, not Friday, either tomorrow or Thursday. Okay, so that's done.